going to talk to us what happens when we do get things right. Sometimes, occasionally, we get things right. And Karla's here to tell us all about Margaret Hamilton, the woman who put man on the moon.
Thank you so much, Val, for that very cool intro. And I thought about that punchline there. I was gonna leave it as a surprise because I wanted to open this presentation by asking if you have seen this woman. So if you are an internet user, I'm sure you've seen this woman before. Yeah. Do I have my slides on full screen? I'm confused right now. Right. Anyway, so I was browsing the internet like as usual a couple of years ago, and I've seen this image. That was way before I thought of entering the tech field. So I was like, what is this picture? This is Margaret Hamilton, the software engineer who built the software for the Apollo 11 landing. Next to her is the stack of printed out code she initially hand wrote. So it was amazing for me to see someone, a woman, writing a code, like building something this big, and then like initially handwriting it before it got printed out. So I was like, this woman is inspirational. And now I'm back in tech. Well, I'm now in tech. And I looked for her again, sort of. And then I actually delved deep into what this woman really is about. So I decided to talk about her today as a way for me to celebrate International Women's Month as well. So yes, we'll talk about Margaret Hamilton, the woman who put man on the moon. Right, so Margaret Elaine Hayfield was born on August 17, 1936 in Indiana. She is a computer scientist, software and systems engineer, and also a business owner. On the picture, the photo on the left is her during during her time in the Apollo space mission. So I really like that picture. And I think, yes. So I want to start with, after her basic info, I want to start with the very fun facts, the highlight, all the highlights of this presentation. First one is Margaret is a self-taught programmer. Second one is she helped coin and popularize the term software engineer. Third one is she invented asynchronous programming. I'm so excited. And finally, the Apollo 11 in-flight software is 100% bug-free. So I feel like that is her biggest flex as a software engineer. That is amazing. So now I'm going to talk about her career before she went on to work at NASA. So this is her official photo at NASA. I decided to use it here because I think it's really cute. So she has a background in mathematics with a minor in philosophy at University of Michigan. And then she transferred to Earlham College, which is in Indiana as well, I think. And then after that, she worked as a researcher at MIT. So she helped develop this weather forecasting software. So back in the day, you couldn't go to school to learn computer science or software development because they weren't established disciplines. So the only way to be a software developer or an engineer is to learn it on the job. So essentially, she's self-taught. And yeah, so she learned it while working at MIT. And then she moved on to work on the semi-automatic ground environment project, which is also at MIT in the Lincoln Lab that worked for the US Air Force. So essentially this project is for, it's a program that detects unfriendly aircraft. And this program is still being used by the US Air Force today. So at this point, she is still a junior software developer. And it's like a tradition in this lab that you're meant to crack some like very hard programs to crack, and these have never been cracked by anyone, and she managed to crack. She was the very first person, not even a woman, the very first person to solve this challenge. And whew, I'm just so excited. And all these efforts she made in this lab made her a very good candidate for the what's this NASA position at Draper Lab, which worked on the Apollo space mission. So when she was working in this lab, she realized the similarities between the hardware people and the software people. So she was like, it's kind of the same, the way you build something with iron and metal and the way you build software. And some hardware peers also agree with her. So that was the time she and two other people, I think, coined the term software engineer. So yes. And now we'll talk about the Apollo space mission, what went wrong, and how Margaret changed the course of history. So first, I want to talk about my favorite story that I've read about her history working at NASA. It's the Bring Your Daughter to Work Day. So this is her daughter. Her name's Lauren. And Margaret brought her to work one day when Lauren was 4 years old. And apparently Lauren was bored and started pressing random buttons and accidentally, sorry, I forgot to mention that it was they were doing a flight simulation, and Lauren accidentally pressed something that ran a pre-launch program during mid-flight. So apparently it's a bug. This bug causes to erase all navigation data and would crash the computer, and the flight wouldn't be able to come back home because the navigation data is lost. And then Margaret suggests a fix for this. And the higher ups were like, nah, our astronauts are well trained. They wouldn't press the wrong buttons. And besides, that's just extra code to work with to debug, so it's not worth it. So Margaret was like, okay, let's just add a comment in the program. Do not select PO1 during flight. It's inserted in the program. And I feel like she also spoken to the astronauts, do not do this. But then selects PO1 anyway. Apollo 11, the next flight. What's the name of the astronaut? Jim Lovell. He presses the wrong button, and then the navigation data gets lost, deleted, erased. So what Margaret and her team did was work the next 9 hours, just painstakingly running through the program, the source code, and then sending new navigation data, and then successfully bringing Apollo 8 home. So her obsession with detecting errors and preparing for them made her a very valuable asset at NASA. And I feel less weird now for like handling ridiculous edge cases when I'm building an app, because I'm like, Margaret did this. Yeah. So next is, I want to quickly show the Apollo 11 timeline. So this was in 1969. July 16, it launches from Earth, enters the moon's orbit on the 19th, and then lands on the 20th, and then they come home on the 24th. So this timeline looks perfect. It looks like everything went well. So what happened 3 minutes before landing? They had a lunar module landing error. So this picture on the left is the Apollo 11 lunar module, and inside it is the display, which started showing a bunch of errors 3 minutes before landing. And it was like, it was whether they pick, it was a no-go situation. They either land or they abort the mission. So in another world, a less ideal world, in 1969, we wouldn't have landed on the moon. We'd still be chasing that dream of putting someone there, putting a flag there somewhere. But if Loki has an army and the Avengers have the Hulk, we have Margaret Hamilton. So, in 2016, former US President Barack Obama said this during the Presidential Medal of Freedom speech, which Margaret was awarded. And he said, "Our astronauts didn't have much time, but thankfully they had Margaret Hamilton. She symbolizes the generation of unsung women who helped send humankind into space." Very cool. So I want to also talk about, I want to talk about, this is the main like chunk of the presentation, how Margaret's preparation put us on the moon. So this is her. Don't know if you can see my cursor, but that is her there with her team. And so Margaret normally just anticipates all errors. And then with this specific software for the Apollo 11, she made use of asynchronous programming. So she prepared, since she got a go signal from Apollo 11 failure, she went to town basically. So she made use of asynchronous programming, which I believe she invented herself. Basically, this allowed the in-flight software to handle errors for high priority tasks first, and the lesser priority task errors did not hinder them. So I was really happy reading this because I'm kind of in a love and hate relationship with asynchronous programming, but realizing now how important it was, and it made us land on the moon. It's so great. I appreciate it more now. These are her words. She said it got rid of the lesser priority jobs and kept the higher priority jobs, which included the landing functions. So basically, if she didn't put these safeguards in the software, there wouldn't even be an option to land or to abort. It would just be an abort. So it was great that she thought of this in advance, and it's quite literally what put us on the moon. This little anticipation. And then I'm also excited to share with you that the source code for this software is available on GitHub. So if one day you decided you want to fly to the moon, you have the repo, just clone it. Yeah, so what's next? Yeah, so I want to talk about some tech advances that were made possible after the Apollo 11. Firefighter suits, same as astronaut flight suits, improved security systems, solar panels, automatic pool purifiers, shock and heart monitors, pacemaker systems, easier dialysis treatments, and many more. So I thought I should mention all this because you know how on the internet these days you always see people saying, why do we keep sending people to outer space when we still have problems here on Earth? But that is exactly the point. We are sending people out there so we can solve our problems down here. So I think it's really cool. Yeah, so I want to finish this presentation by sharing the quote that we all have heard before. So it says, it's from astronaut Neil Armstrong. He said, "One small step for man, one giant leap for mankind." But he was actually misquoted for this. What he actually said was, "That's one small step for a man, one giant leap for mankind." He insisted that man and mankind were essentially synonyms of each other, and so it wouldn't make sense. So he insisted that this is what he said. He was just misheard. And I was like, okay, I want to make a spin of this quote and say that Margaret Hamilton's contribution to technology is one small step for a woman, one giant leap for womankind. So yes, that's it. Thank you.